Hello, everyone, and welcome to our session today. I'm Hoda Bukadra, third-year student at Trinity College and the Google Developer Student Club lead at my campus. Today, we will be having an introduction into blockchain as a part of our solution channel preparation. And for today's session, I would like to introduce Daljit Singh, who is our workshop and talks co-lead and a third-year student as well. Hello,
Yeah,
Daljit, and the floor is yours.
yep. Hi, my name is Diljit Singh. I'm a third year student at Sheridan. So I have worked as a developer at a startup, small enterprise, and large enterprises. In this workshop, we'll talk about the blockchain. So what is blockchain? What is DLT? And how does Ethereum work? Then I will do a live transaction on 3 minutes to understand what's a block and everything. Then I will talk about the current stuff in crypto world, DeFi, NFT, DAO, and a lot of stuff. In the end, there's a QA, so you can ask me like any question. Again, this is a workshop for introduction to the blockchain. So the main stuff is just to understand what is a blockchain. There will be more workshop in the future to understand more like what smart contract and other stuff. So here it was introduction to blockchain for beginner. Hello. So again, this is my main stuff. Yeah. So here's stuff. So we'll talk about what's blockchain, the definition, DLT. DLT stands for distributed ledger technology, and how the blockchain like relate to DLT. How does Ethereum work? So a lot of stuff, account, transaction, and also a live transaction on Ethereum network. Then what is happening in crypto world? The current use cases, which would like DeFi, NFT, and other stuff, also like something beyond finance. There's some top blockchain like Solana, Cardano, Polkadot, Avalanche, and that stuff. Then CBDC. So this stuff in the end. Then a QA. So let's go. So what is blockchain anyway? So blockchain is just more the chain of a block. So here. So by concept, blockchain is based on peer-to-peer topology. So now most time we have something called a central server. So in a network, there's a central server. Central server like do everything on that the master copy. So central server has a database. It like totally manage that database. But in a peer-to-peer topology or in the network, we can have multiple server or multiple node or multiple peer. All these peer are just a machine in the network. So first they have multiple peer. There's no one central server. They're multiple. Then it's a distributed ledger technology. It stands for just a database that is shared by multiple member. So simply they they have multiple server or multiple peer. There's simply multiple machine in the network. Then each of this peer have a local copy of that chain on the machine. So blockchain is simply a network, peer to peer. Then all of them simply have a I share the whole copy. So simply they have a local copy on the network. Each peer has one copy on the network. So simply technology, a peer topology is a distributed ledger technology that allow data to be stored globally on thousands of servers. So that's blockchain. A network of peer, they have a local copy of the chain and they maintain it. So now a little more deeper. Blockchain is a type of DLT. It's a type of distributed ledger technology. The distributed ledger technology actually is a very old. It's from the Roman Empire somewhere there. Blockchain is like very new. It like started somewhere in 2008. The Bitcoin. So blockchain is a type of DLT where transactions are recorded or grouped in a block. A block is simply a collection of multiple transactions. Each new block include a hash of previous one. So let's talk about first hash. So this is called a this is a hash algorithm. So it stands for secure hash algorithm 256. 256 stands for the 256 bit the value here. So hashing simply is a way in which we take some raw data and scramble it in such a way that we can't reverse it. So I will select one. So I take one. I simply like scramble it in a way that I get this hash. I can't reverse this hash. If like I give you this hash, you can never find one. You can never like reverse it. So that's hashing. Using secure hashing algorithm 256. 256 stands for the 256 bit. So this has actually 256 bit in size. This algorithm is used by Bitcoin. So again, So I type something here, simply take the data, scramble it, make a hash. I can reverse the hash, mean stuff. So again, one more stuff. Like even I type like 1111 lot one here, you can see it like always get a fixed length of hash. That's like this thing. Every time the hash would be 256 bit in length. So that's the stuff. So I can reverse it. It has fixed length. Now some use case. So hashing is used for data integrity. So if I like type one here, okay, somebody like type two, it change the hash. So if anybody tamper the data, we can find. So one has this hash. So anybody like type two, we can find that they did something with the data. So it's used for data integrity. The second use case is actually as ID. Hash are unique. So even like type. So so here's B for B. I type 2918. Let's go for one. B for B. One will always has this hash. It's like just related. It's like this hash uniquely identify one. Hash always uniquely identify the data. So again, the recap. I type something here, scramble it to a form, I can reverse it. Then it's also advanced unique. Also used for data integrity. If I type something like here, it change. This is the main stuff in hash. Also it's fixed length. Always would be 256 bit. This hash actually is for Bitcoin because it's this hash. So again, I'll go back here. So now we go to hash. So every block actually include a hash. It includes like its own hash and a hash of previous one. So I will explain now here. So right now, just think about this thing that their data, one, everything. So I know I'll explain this data later in the mining when I explain what is mining. So right now, just understand this block, this nouns, this data, and this previous hash make this hash. Okay, all this thing create this hash. You can see that this hash is present here. You can see 157, 157. So here, then this block, this nouns, this data, and this hash match this hash. This is present here. So it's changed. This hash here, then this hash here. This go on. So what happened is actually when like a type one, I change the hash. Since like so this is a combination of block, nouns, data, and previous hash. So that's why like the blockchain is immutable. So when I change anything, it change this hash, it change this hash, it change this hash. So it like go on and on. So this whole blockchain is now invalid because change the hash. This is how like this is a blockchain. How is the data structure? It's a structure in this way. Every block contained hash of previous block. The first block, Genesis block, simply don't have any hash. Or they have zero or they have no hash. The previous hash. So every block would have the hash of previous block. You can see this hash go here, this go here. It is changed, so it get changed. If I change anything, it change the whole blockchain. So it become invalid. So here again, it's a type of DLT where transaction are grouped into block. Each block include a hash, simply a large string, which is simply a scrambled form of our data. It will include a hash of previous one, and they get chained together in a way that it become a chain of a block, or simply a immutable decentralized database. So let's recap. So here we talk about how a blockchain is a peer network. There are multiple peer. Then everybody has a copy of the chain on this peer. Every peer has a copy of chain. Okay. Then we talk about how this chain we have block. The block just as a collection of transaction. Then each blocks are linked to each other. So if you change one block, other block get changed. So in that sense, it's immutable and it's decentralized. Simply there's no one central database. Everybody has the local copy. So yeah. Then I will talk about the Ethereum, the world unstoppable machine computer. So here we go learn what is a blockchain definition. Now we're going to talk about Ethereum. So I'll explain this stuff. Wait. So first, let me just give a definition. What's Ethereum? So what it stands for? So in the Ethereum universe, there's a single, this means valid. The single valid machine or computer is called Ethereum virtual machine, whose state everyone on Ethereum agree on. Everyone in the network simply have copy of this EVM on a local machine. So I'm go here. Yeah. So this is a Ethereum node tracker. So we can see the all nodes simply all machine in the network at the moment. They actually we have more. They actually lot of node, but it's like that right now. But how many we have? So here. So this node they have the local copy of the EVM on their machine now. They also have a local copy of EVM. So every node here have local copy of EVM. But even they are like thousands of copy at this moment. They still agree on one state. This is the valid copy. So that way, even if we have like thousands of local AVM at this moment, like people running AVM on their local machine, still they agree that there's only one, like they agree on one that this is the right thing in the EVM. Just make it one giant large machine. So that's why it's called the world unstoppable computer. So first it's world because it's global. It's like everybody has EVM. But still they agree on one state. So state is actually what happened at a moment or data at a given moment. So
Dajit, I think we are having a question.
okay, so want to change the data. So it's okay, but if you want to change the data, you can't change the data. So this issue here. So let me explain. Oh, sorry. So why we can't change the data here? When we change the data, we change the integrity here. This stuff here. So I can show you here. So what happens is actually that every peer has a copy of the chain. So let me say I'm this peer A. So I want to let's say mess with the oh stuff. I made something. Hello. Okay. Hello world. I got it. So whole chain got invalid. Okay. I'm gonna simply I'm gonna go to a network and say this is my chain. I'm gonna like broadcast this chain to every node, every people, every machine in the network. They're gonna see this chain. They can compare their chain. They can see like we have this hash. This guy has this hash. They will not accept my chain at all. Because so this peer will talk about this peer. They have the same hash. They have same copy. They're gonna say that my copy is invalid. First, this hash is wrong. Then my copy is different from every network, from everybody. I can change my copy, but I can change a valid copy that everybody have. This is a valid copy. If I want to change a valid copy, I need to mine. I do something called mining. Mine is simply like creating a block and add it to the chain. I will broadcast to everybody in a network. They will verify. When they think it's the right chain, they will accept my chain. And that this chain will be updated. That's why I can't change. If I change my local chain, these people will say they this is not right chain. They have their own chain. They all local copy. That's why you can't change it. It's by like it's immutable by design. You can like put data here, but the design is like that way that you simply can't change it. I'll explain actually one way how you can do attack on blockchain. Mostly to do mining. So yeah. So any question? So Rama, so can you explain with the business use case scenario? So it's more like this. So now Ethereum, there are like lot of money on Ethereum. Really, Ethereum is actually the 27th largest asset in the world. It's more worth than a Walmart and any university at this moment, any bank. So we have a lot of data on Ethereum at the moment. So even like I can go to Ethereum, I can get the local copy, I can make my chain, but I can't never like make other people agree on the chain. There's some rule. I need to follow that rule in a blockchain. Blockchain is simply a code. It's like a code or a protocol. It's a set of rules. So Ethereum is like a use case scenario since it has a lot of money on it. Like people use it for many things. They have transaction. They also something called a smart contract, which is simply a code on a blockchain. So I hope I answered the question right. So yeah. So I think let's go on here again. Yep. So like let's say how I explained you that this is the issue is here is actually even they have the so many like local copy on the network. They ask one valid copy. So any change happen, like I would say this, like them say I have 12 ether or 14 ether. So I have two state, 12 ether or 14 ether. Okay. The blockchain, I should have only one state. Either have 12 or I have 14. There's, I have 12 ether or 14 ether. This is actually a cryptocurrency of the Ethereum. So I can say like $12 or $14. So when I have 12 like dollar, I want to be 14. So I need somebody to do transaction to me. So that's the question. So Rishabh, my question when data is entered and alert. So my question is when a data is entered and entered wrong, my mistake, all data is collected in a block. How do I enter data again in the new block? So you do a mining actually. So what happens actually? So if I want to like do a transaction on a network, I simply send a transaction to network. This all miners simply take my transaction, they take a block, put all transaction in the block, then they do the verification. They verify if this transaction is valid or not. Then they mine the block. Mine in the mining mostly they are simply are solving a very complex puzzle. After like mining it, they mine the block, they simply broadcast to the whole network. Then whole this node take the chain, whatever like you broadcast to the chain, the copy. So simply the chain that we added a new block, we broadcast to the network. They take the copy, they verify if it's right or wrong. If it's right, they accept it. Simply how is everybody will accept it at some moment. So this is how it happen. They have local copy, everybody have local copy here, but they still have one valid copy. Like anything change happen, if change that change is valid, they will agree. When they agree, everything change. Like everything will be updated. Everything will get updated. And we have like thousands of local copy. We have thousands of Ethereum virtual machine on their local machine. We have thousands of Ethereum virtual machine here, but still they agree that there's only one valid EVM. I'll explain it mostly to mining like how it happened. Now just believe that even they have multiple local copy, they agree that there's a one valid copy, one valid global copy, and that's EVM. That's why its words computer is global.
So Daljit, I have a question.
Yeah.
So when the data to be changed, does it create a new node or create like a new chain?
So you actually create new chain. So to explain the stuff, yeah, let's go here. I'll
Thank you.
explain it. Yeah. So oh yeah, blockchain. So blockchain is very complex. It's actually a protocol. They are a protocol. This is a sensor protocol. So here, everybody has local copy. When they add a block, they add a block to this copy. They're gonna broadcast this copy to this peer P and peer C. So in that sense, it's a new copy. They have an old copy. They if they think the copy is right, they're gonna update their copy as well. Then at once, this all peer A, B, and C will have only one copy. That's a valid copy. So yeah. So you got it? Should
Yeah, absolutely. Thanks a lot.
yeah. So again, the blockchain is very complex. They are like a protocol. So Bitcoin was a protocol like for cash payment. Ethereum is a protocol for running our dApps, decentralized application. So they are actually very complex. But still I will try my best to like explain to you. So still, yeah. So again I said the same thing. Even they have like multiple copy, they agree on one copy. Like as I said, like somebody will make it a copy broadcast to the network, they're gonna agree that yeah, that's the right copy. So in that sense, we only have one valid master copy, one global copy. And in the Ethereum, we have a virtual machine actually. We have a Ethereum virtual machine. Every node has a Ethereum virtual machine on their local machine at this moment. They agree that this is only one valid state of that here. That's why it's world because even like it's global. Everyone have it. You can have it as well. You can run your own node. You can get the copy if you want. It's global. Also, it's single. It's only one. In must it's a this is only one valid at a point. So it's global, single world's machine. It's unstoppable. Why? If let me say, so if I want to destroy Ethereum, it means that I need to destroy every like node from every country. So like Canada has 229 nodes. I need to destroy all this node. Then go to US, go to Mexico, go here, Brazil, go to China, go to Russia. You can't stop it. Ethereum has a 0% downtime. It's never offline. It never go offline. So like now we have like this much node. Yeah, we can see that. So you know, say like some people went down. Japan, some people went up. So that's happening. That's unstoppable. Like nobody can stop it. It's like zero downtime. You can't destroy it. Since you need to destroy the whole world, maybe you need to destroy the node from every country to stop Ethereum. That's why. So it's a world machine in some sense. Yeah. So let's share again. So, yeah. So the same stuff. Then this node can broadcast a request to perform any computation. This actually means code. So pretty much in Ethereum you can do more than a transaction. You can actually deploy your code to the EVM to the machine, and even we can execute that code. That's smart contract. That's a Ether. So Ether is a native token or cryptocurrency of Ethereum. Ethereum is a blockchain. Ether is a cryptocurrency. So we use Ether to pay for transaction. If I do any transaction, you pay some Ethers. Like it's like act as a transaction fee in some sense. So we know little bit now what's Ethereum a little bit. Slow go again. Now I'll explain like some fiat and cryptocurrency. We need this knowledge because I want to talk about account next. Fiat currency, cryptocurrency. Fiat currency is actually physical medium of exchange. Every fiat currency is like the US dollar. So very high level would be fiat currency is simply a currency issued by the government. Cryptocurrency currency issued by a blockchain. Fiat currency are mostly like physical, like US dollar, Canadian dollar, Indian rupee. We have the physical like paper. So so you can do anything actually. So let me say so Marcin, what are the use cases of smart contract? So let's say Marcin, maybe I like pronouncing your name wrong or right. So sorry. Let me say I want to borrow $500 from you. Okay. So now what we need to do, like I want to borrow $500. You don't know me. We need some trust, right? So we need maybe the third. We need like get a third party and like them to do every stuff. Like we don't have any trust for ourselves. Like I don't know who you don't know me. I can't get that money from you. So third party will come, they will like make a contract, anything happen, they resolve it. Smart contract is the same thing. So now with smart contract simple like that, I want to get $500 from you, borrow $500 from you. I write a contract in Solidity, deploy it to the EVM, and then it will do everything for us. First, it will like see if you have $500 or not, 500 coin or not. After seeing that, it will ask me something like if I write like maybe I can write from my account, give Marcin 100 coin every month. So when you give me the 500 ether, my account by default it will start giving me the 100 ether every month to you, 100 coin every month to you. So with a smart contract, you can do anything you want. It's simply a code. It automates a third party. In real life, it's simply if a two party, they need to build some trust. They trust each other. In a smart contract, you take the trust automated with the code. You can do anything. You can borrow, like you can code for a product for borrowing. It's like for borrowing cryptocurrency, for maybe for lending cryptocurrency, for swapping cryptocurrency, for anything. You can do anything. You can automate third party from the any stuff. So how I hope like answer the question. So I will talk about a smart contract a little bit after. Yeah. Right now, simply explain the currency. Fiat currency, they're physical, like US dollar, that stuff. They're digital. There's no physical. They're simply a bit. They're simply like a data. Fiat currency issued by the government and central bank. Government like decide everything, the rule, regulation, everything. They issue it. US dollar, Canadian dollar. Cryptocurrency, they issued by the blockchain. Blockchain, the code. The code define everything. The code define how many coin would be, how they gonna get to the people, everything. Blockchain do everything for us. This is the whole code. Example: Bitcoin, Ether, Sol, Atom. Ether is the cryptocurrency of Ethereum. Everything we do in Ethereum, we need to pay some Ether for it. Account. So what are account? So in Ethereum, account is simply an entity that has some Ether, the balance inside it. Let me show you maybe. Yeah. So here's my account. So I have account in Ether. So I have some Ether here. So simply for Ethereum, I'm simply an entity that has some balance. So this is my account. Yeah. Let's go again. So again, account is simply an entity with Ether, a balance that can send transaction on Ethereum. So there are two types of account. Externally, at first, externally owned account. So this account I mostly use a control account. So this account is my account. It's the EVM or machine Ethereum. It call it something called a externally owned account. Says it's owned by me. I'm a human. So for that, any account that's like controlled by a human being, they're called externally owned account. Let's go again. Any account is user control or controlled by human being is externally called account. Contract count. The smart contract is actually a count. So Ethereum virtual machine or Ethereum, it see the contract account as a type. It simply see like smart contracts are like a type of account. So smart contract is simply a code we deploy to the Ethereum. That's it. So to count a account by a human being, smart contract are simply a code. They both can receive, hold, and send ether. They can have ether, they can hold ether, and any other token. There's some more token. I will talk about later. Moreover, we can interact. The bottom can interact with the other smart contract or with the code on the EVM. There's a one difference again. This account, the account controlled by human being, can initiate it can send transaction on the network. But the smart contract, it can only send transaction when it receive a transaction. So in the code, you can actually write a code to send transaction. Contract get executed only when we make a call to it in a form of transaction. That's only when we execute a contract or simply a code on the Ethereum. So I think this will be better to explain now. I'm going to talk about the account, externally owned account, the account mostly managed by people or by the human being. So you can see like public and private key here. So right now, simply think the private key is like a password, public is like a email. So like if I send my email in the chat now, you can send me I send my email address, you can send me email to that email address, right? Private, but if you want to like see that email that sent me, you need some password to like to log into the account. So that's private key. Public key is like email address. You can send something here, but to see any email that's sent to the email address, we need a password. That's private key. In reality, private key is simply a huge number like this one. You can randomly generate it. So from this key, public key is generated. Private key, public key is generated for private key, and it's actually a hash. It's simply a hash. Like hash is irreversible. So this ship, who are the people promoting promoting a smart contract? What is so who are the people smart contract is code? So what happens actually to deploy a smart contract on the EVM, you write a contract, then you make a transaction to the EVM, it gets stored. People write a contract, they make a transaction EVM to store the on that copy. When we have to execute it, simply make a transaction again to that copy, and that's it. I will explain that maybe later about smart contract, how it happened. Maybe like the start to finish, everything the compile like the source code, byte code, and op code. Yeah. But at this moment, simply understand public and private key. So again, public key like email address, you can send the email here. Private key is the password to like to see the email that is sent to us. Simply it's a number, you write it here, it get a hash. That's it. Now we're gonna use something here. Let's generate random one. Yeah. So how can we use public and private key? So it's better. Hello. So I'm going to show you something called a signature. Signature are a way to validate a transaction or a document. So I have a message of hello world. Okay. Then I take this private key here. Message plus private key. When I sign it, it creates some sort of message signature. It's a hash. It's again a hash. So message plus private key, we get a signature. Then we take this signature here and public key. It's the same key, and a message. Again, and sign here. We can verify it. So simply it's like done this way. So I wrote something called hello world here. I want to prove to other people that I am the one who wrote this message. So I will take my private key. Private is a private and like give this key to nobody. This is like only mine key. I give like we never share it. So I'm gonna sign it. I'm simply gonna take a message and private key. I'm gonna sign it to create a hash. Then I'm gonna send this message public key. Public is like again yeah, email address. You can share it if you want, and a signature. I'm gonna like send it to the internet. I'm gonna send my message, public key and signature. So people who want to verify this is my message, they can take a message, public key and signature, and click verify. So it's right. So let me say I wrote something called hello world one. Okay, assign it. So here now here I wrote it hello again. So one here I'm gonna here and a message. So simply like somebody took my message and he like related a one. Okay. Now if I take a message, public key and signature, verify, it's wrong. It's simply a way to validate the stuff. To validate maybe a document or transaction. So simply you can take a message, take your private keys like a password, sign a signature, message signature, signature hash. We take the message, public key. The key we have is public. It's like email address and signature. When we verify, we can prove it is our signature. Again, nobody can reverse the hash. You can't reverse the hash to get a private key. The key we use, the transaction. Now I prove it like so. What? How they use it? So what happens actually? So a user simply have three stuff: a private key, public key, and public address. So to send a transaction, we use public address. I'll talk like how they get generated later in Ethereum mostly. But simply say, I want to send to somebody like a transaction. I need their address, public address. So this is public address. This would be my address. Okay. When I send a transaction, I will send a transaction with the private key. It acts as my password. Nobody knows this is the key. I take a message. There's $20. Send from my account to this account. Their address. This is the value. This is private key. I'll sign it to a signature. Then it get to the node. The people who mine the stuff, they verify it. So simply I take a message that this is the address and the signature. They also take it up public key. They put all the three together and click verify to find if it's right or not. So like if somebody like so I might not get my transaction right. So minus the maybe like here I can add like 40. Like mess with a mill of 400 or 40,000. But what will happen now is actually I click verify. You can't. To sign a transaction we need private key. If that node can get my private key, then he can do the transaction on my behalf. But if not, he can never can do it. Now a little about Ethereum, like how Ethereum use it. So private public. So here, private key is a password we use to sign a transaction. It's used to send fund. You give this key to nobody. Okay, no one. To send fund. Okay. Then when we sign a signature, we also list public address again. So we're gonna sign the signature. When you get to the node, they verified using a public key because the signature which comes from a private key in a message get reversed to the only public key, but never to private key. They can get public key, but never private key. Then they verify this public key again from it. Address which is receive fund. You can never be sure. So maybe I pronounced your name wrong. So Rosaline, sorry. If you send it to the wrong address, how can we sure you are sending it to the right address? So for that, something we have called ENS, Ethereum Naming Service. So first, sometimes people used to simply send to like the wrong address. I don't even know where to like get it back because the ledger is immutable. The blockchain is immutable. You can't revert it back. So that's a big issue we had. Now, Ethereum has something called Ethereum naming service. You can get something called like I'm using. I can get something called legit.eth. That ETH can be connected to any account. So that's a new way now have like we had domain name like something called google.com. It belongs to the Google. So you can get the same thing. So now you know the google.com is again stand for some IP address. So same thing. Now we have something called Ethereum name service. If you don't want to use this huge number, you can register for that for a name. It will be unique. It will be some name dot eth. So that's a new way like to make sure you send it to the right address. So maybe I should like me explain like better way. So again, public. So I take somebody public address, the huge string. I take my private key, take the message, send my this money from this address to this address, sign it, get to the node. They're gonna reverse the signature hash to find a public key to verify the thing. Nobody can change anything. Nobody can ever like they can never take my coin away. Everything. Even like here, I can show my coin. So if it's like I send my this address to anybody, this is my public address. Nobody can ever get my coin. They need my private key. That's the main thing. You can give your public address public to anybody, but never give your private key to anyone. So again, sorry, maybe I pronounced your name wrong or coward. Can you change the private key in case of so the actually you can't change the private key. You can't change a private key actually. So I'm gonna explain now. Yeah, private key is this one byte, 32 byte, 64 byte, and 21 byte. So here, you can't change a private key. There's an issue here. We first generate a private key using any open source Ethereum library. Then we take the private key. We use this algorithm, elliptic curve digital signature algorithm, to generate public key. Then we use one more algorithm, cache 256, to generate public address. So you can't change your private key actually. You can't. It's simply a hash. That's a big stuff. You can never change your private key. It always will be the same. It will always stay the same. You can't. So that's stuff. So we have three stuff. Private key, address, use like a email address. You can if you have to send anybody fund, you need this public address. To send fund, we need a private key. This private key to sign to make a signature. Public is used to verify the signature. And that's it. So private key is very long, 32 byte. Public key is double size, 64 byte. Address is very short, 21 byte. That's why we use address. It's very short. Moreover, there are three way. Like first, you use any library to get a private key. Again, so there was something called a Ethereum J. It was a library to get private key. They use something called secure hashing algorithm 256 to get a private key. Now they it's like no more. Like they stopped the library. It doesn't function no more. But still, you can use any library to get a private key. Then you need this algorithm to get the public key. Then if we take a public key, we run through this algorithm to get the address. So this three way. You reverse this thing to public key, then to private key to get a private key. And hash are irreversible. You can't reverse it. So any question about the account first? So any question here? So if you don't have like any, so I'm gonna like do a transaction. I'll show you again like what are we doing again through a transaction. So again we talk about what's a transaction. So on Ethereum, transaction are like instruction that account give to the network. Simply like instruction, send this money to this people or this guy. An account will initiate a transaction to update the state or of the Ethereum. So what's the state first? So state is anything at a given moment. So this is look here. This is wait. This is state one. So Hoda has five ether, which is zero ether. It's a state. State is simply something that is happening at a given moment. So Hoda give a instruction to give send two ether from Hoda to my count. So state A is simply Hoda 5 ether, me 0 ether. Instruction or transaction simply instruction to simply send this 2 ether to my count. Now that there's a new state. Hoda has 3 ether, I have 2 ether. So that's the whole state. It seems like a transaction based state machine. It can have multiple state, but only one state at a moment. So Hoda can have like 5 ether, 7 ether, or 8 ether. But at a moment, she can only have like one. Other can have 5 or 6 or 7. But she can change. Like if I send one ether to Hoda, now 6. I send one more, now 7. A state machine can have multiple state, but only one state at a given moment. Ethereum is like a transaction-based state machine. Transaction act as an instruction to change a one state to another state. Transaction can change current state to another state. The most simple transaction on Ethereum are simply send ETH, the cryptocurrency, from one account to another account. So that's transaction. So other stuff related to a transaction, how transaction happen. So every transaction require a gas. So gas is like a transaction fee. So what do we do in Ethereum? We need to pay some money for it. We need to pay something in ETH. Again, the cryptocurrency. So gas is like a unit. It's a unit. It's a unit that assesses the amount of. So it's a, like very hard. So simply it's a unit that assess how much work should be done to execute that instruction or transaction. So here. So now when like node take this instruction that send this stuff, they need to first need like they verify the signature, validate the transaction. They need to mine a block. So that's two stuff. Okay. When to mine a block, add to the chain, the storage or the size of chain increase. So that's why we're using CPU power and storage. We're using two things. So that's like how much stuff need to be done to simply change the state. So so we need to pay some gas for it. Why gas is a necessity? Why we are paying something on this network? So gas protects the Ethereum from bad actor. So if there's no gas, anybody can come, they can spam the network. They can like say send this transaction, send this transaction. It helps us. Help from the spam. Moreover, all this gas we pay the transaction fee, it go to the miner. Since the miner took my transaction or whatever took the transaction, the miner did multiple things. He used CPU power. He also like the storage got more, so he need to store more data on the machine. So that's why. So that's the gas, the block. Same stuff. It's a collection of transaction. It contains the hash of previous block. Mining. How mining happen? So now I will explain. Yeah, yeah. So I now explain the mining. So what's mining? So again, from start to finish. Ethereum simply is one large machine. I would have local copy of the network. We know cryptocurrency is a digital money. Account is something that hold that money. This account is simply controlled by the human. Transaction or instruction to just simply change one state to another to new state. The current state can be changed to new state with any transaction. We have gas, we pay some transaction fee for each transaction. Block is a collection of that all transaction. Mining process, we create a block. This is very high level of what happening in mining. So for a sender signed the transaction with the private key. So we use the message like I want to send this money from this account to this account, and we take the private key and sign it. It create a hash. Then they simply broadcast it to the whole network, the whole node. Upon hitting the new transaction request, each miner or simply node in the Ethereum network add a request to their local mempool. Mempool is simply a pool of unconfirmed transaction. If I send my transaction, it takes some time. So it's not confirmed yet. So simply they add to there's a huge pool. So transactions are coming that to that pool. The all the unconfirmed transactions are in the pool. At some point, a miner will take or request or transaction and add into a block. So he took some transaction from the or the node took some transaction from the pool, add into a block, then he verify all the transaction. The signature is right or not. So if I had the fault private key, my signature would be wrong. So my signature is wrong. If I try to maybe send transaction, maybe send 100 ether to this account, I don't have that much. So that's an invalid transaction. So all invalid transaction that is rejected by default. All the valid transactions stay. Then they execute a code of each transaction. So again, let me say this was a copy. The node had this copy. Hold the 5 ether, the G0 ether. This was an instruction. This is a transaction. So when they execute this code, they get new state. So they now the state is actually say that Hoda has 3 ether, I have 2 ether. So this is new state. So they execute that transaction to change the local copy. Local copy will be changed. Yeah. The miner start producing proof of work. So what's proof of work? Yeah. Here. So this is actually what is happening. So this is whole block, let's say. So let's say this is our block. Okay. Or maybe this one. So let's say the last block. Last block. Okay. So this is our transaction. Send this from this much money. What is proof of work? If you see this block, you see that the hash we have is 50, 40, 40. They'll start with 40. They'll start with 40. This is a problem. This is a proof of work problem. A proof of work. So there's a problem we need to solve to make a block valid. It could be 50 in the front of the hash, or it could be 18060, something like that. Also could be this hash should be smaller than this hash. Again, this hash should be smaller than this hash. So this proof of work simply is a problem that miner need to solve to make a block valid. This problem is always with the hash, this hash. Now it's a new problem we have. We can't change this block. Now we can change transaction. Now we can change this thing. So we change something called nouns. Nouns is simply a number used once. It's used to get this thing. So I'm gonna first take this out. Okay. Now we take this out. We get this hash. Okay. I don't want this hash. I want the 40. I want my chain of my block to be valid. I'm gonna start by one. I got 1 0. So maybe two. Again, 1 2 3, something more. So they're simply doing this stuff. They simply change the value of nouns every time to get the 40. I'm gonna run mine. So here. So I got it. I solved the problem. I got with this nouns with this number, I can get 40. This is proof of work. So when miners solve this problem that you need to with this much zero, this much stuff, the problem is solved. That's proof of work. That's the problem of proof of work we have. We always change the nouns. It's a simply a number. Number used once, number used to find this hash. Here. When number they find proof of work, they solve it, they simply broadcast the whole block to the network. Other node hear about this new block. They simply first they verify the hash. They see if it has 40 or not. Okay, they verify the hash. They execute all transaction. So again, Al Qaeda, what is the chance of transmitting Hoden Daljit? So it would be more like so about after this, like this slide, I'm gonna do a transaction. Maybe I can show you like in the real way on Ethereum network how many it's gonna charge me the gas. I will show you that way. So first, let me complete this stuff. Like let's end this slide first. So they verify the certificate. Does it has 40 or not? Execute all transaction block themselves. If I somehow I can take the software to mine the block. I can maybe change the source code of the software to to accept invalid transaction. Okay, so I made a software in a way that it can change, like it can accept invalid transaction. Even that thing can accept invalid transaction. But when I give this chain to the other node, they have the valid software. It will see that thing. So they can see if the transaction are valid or not. If it's not valid, whole chain is rejected. So here we need 40 or some other type of desktop like the 40 or something like that format. We need all transactions should be valid. When they are valid, when he the simply the node verify everything, that block will be added to the tail of the blockchain of that node. Simply, I broadcast that block to everyone. They simply verify if it's right, they add to their chain. Then they start mining on that chain. In the end, each node simply remove all the transaction in the new block. So that block, all transaction we had, the local mempool, the unfulfilled, like the unconfirmed transaction, they're gonna take it out from their pool because they know that it could confirm their block. So this is the mining. So again, sender sign the transaction. They give it to this broadcast request. Miner pick the transaction. They put in a block, verify the transaction, execute the transaction, find a hash, broadcast to the whole network. They take the block, verify it, if it's right, add to the chain, done. In the end, simply like any unconfirmed transaction, like so in that new block, we got all the transaction. They simply can remove all the transaction from dim pool. That new transaction in the block. And that's it. So again, any question? Now I'm gonna make a transaction on the network, like to again explain the stuff. So first, any question?
I'm looking forward to the practical part. Thanks, Daljit.
Yeah. Actually, by default, like Ethereum, they are very complex. So Ethereum is like a protocol. It's not a ledger actually. It's a set of rules that define everything on the network. So that's why it's very difficult to even to make this like for to define Ethereum. You need like 2 or 10 hour workshop to like to describe what is Ethereum in one sense. So let's do the transaction. So first here, this is my wallet, my address. I have it here. Okay. So MetaMask is a plugin, a wallet. It simply help me to manage my account. I have 3 accounts. I'm gonna take this account. I'm gonna send my transaction. I'm gonna simply send this transfer to my other account, to my trust fund. In the Ethereum network, we can do the minimum. The value of the transaction, should be zero. Could be zero. So minimum amount I can send in Ethereum is zero. If I do maybe like negative 400, next it is zero. Okay, I'm gonna transfer maybe 1 ether. Yeah, 1 ether. Next. Okay. So now I'm gonna explain the gas. So first, I'm gonna send 1 ether. This is a gas. So miner can pick transaction, whatever transaction they want to include in a block or not. Actually, since the gas fee go to them, so we need to select the gas fee. Advanced option. This is gas limit. This is actually said we need 21,000 step over This is unit. So we need 21,000 steps to execute this transaction. It include everything. We need this much CPU power, this much data. This is the gas. The unit of how much work should be done to execute a transaction on the network. We 21 is by default. You can make more. If let me say you want to, I can do more. Let me say we can do 4,000. So this much. I'm saying that a node might need this much power to execute a transaction, not a fee. So this is a tip actually. So this go to the miner. It will simply go to the miner. This is a max fee. This gas will provide this fee. Okay. Let's save. Now this much. This much gas I'm gonna spend. It's simply like it's a gas by max fee. It's multiplied like 4,000, 40,000 into this much. Save. Confirm. I'm gonna go pending. Let's show me the block here. So this transaction on the network now it's like going to the miner. So this is hash, unique key, status, the block, which block it can go, the time it can go from my account to other account, one ether, the fee. Again, yeah, it goes sent. Yep, good. Indexing. So they are simply now the transaction are being stored. The block actually being stored in the chain actually. They're propagating the block now. You know, take some time to to get it confirmed. So yeah, this much fee got charged for me. Still, the block is not a so block is not being accepted by every people. It got confirmed, yeah. Now, so this is my stuff. Now, every node in the chain has this block. The block, the block has this transaction actually. So I will show you the block. So this is block. This block has our transaction. Timestamp the transaction. I click here. The 26 transaction. Somewhere I have like so my address is somewhere here. Somewhere here. Okay. Block height, number of block we have, time. Simply 1 minute ago it happened. The transaction, it had 26 transaction. Now there are internal transaction. Internal transaction are like so the smart contract when it get executed, it can do transaction. So this is transaction done by the smart contract, mined by this miner. So we can see this account. It will take time. So this guy. So this is address. I can see only the address only. And what he done, like he did this is my transaction. It's public ledger. I can see the whole transaction he's doing everywhere. Okay. Mined by this guy, block reward, 0. I'll explain why it's 0 later. Difficulty, how much time, like how difficult is to mine this block? Size 36 byte. 36 this one byte. Gas used. This is how so this is how much they charged. So when I send a transaction, let me say I put too much on gas. I'm sending 2 ether. In the gas I put 1 ether. Okay. But sometimes what happens, sometimes when I execute a transaction, maybe it might use only 0.5 ether. So when that happened, I get refund for the gas. So it means just this much gas. This was limit it should use. This was maximum it can use. It is this much. This was a fee. This one got burnt. So Ethereum was used to give the whole transaction fee or the gas fee to the miner. Now they burn something. So burning is simply this ether are taken out of the circulation. So simply they're taking this ether and send it to a account that has no private key. So when you send a ether to account with no private key, nobody can access that account. So that account will be logged. Like nobody can access it ever. So in that way, this ether will never be used in the network, never. So they're burning it. So in real life, you can do like if you have $500, you can burn $100. Burn with fire. You can put it to fire. In Ethereum, you can also burn it, but send it to account with no private key. You send it account, that's a only public address. Nobody know the private key. So Martin, can you provide data live and be secure on the blockchain if data is immutable? Or would it be more to host a private blockchain? So actually, if you want privacy, you should not use Bitcoin, Ethereum, Solana by default. Like I can see this whole history. This guy, like, this miner, I can see everything. The whole transaction. It's taking time, by the way. So yeah, I can see everything. So he got some money, he sent some money, he got money, sent money. So for the private, it's better to use a blockchain for you, like your own company. Simply make it private. So there's something called Monero. It's a private blockchain. They're private in a way that when anybody send money to anybody and amount is confidential. It's private. Nobody can see anything. Monero is used by multiple criminal. Even the ERA, the Internal Revenue Agency of US, put some bounty, like some type of bounty on the Monero. Anybody can crack the code of Monero. Monero is very private. It's used by criminal and pretty much everybody. So in Ethereum, I can see everything, right? Ethereum, in Monero, I can see nothing. In Ethereum, I can see whole transaction, everything, how much like the Ether he has. So I go here. Uh, Again, take time. So this one Ether, the whole transaction. In Monero, I can't see this thing, not I can see this thing. That's for like, so if you want to use a public record, or like if you want to use something like health record, private document, it's better to have a private blockchain. You can run your blockchain inside your enterprise. Now this blockchain is public. I can join. You can join. Actually, you can install MetaMask and you can make account. So let me. If I want to make account, I go here again. I just use wait. Sorry, create account. Yeah, here. So I got a new account. Okay, it's public. Again, let's create one more account here. So it's a public blockchain. Anybody can access it. If you want, if you like some private data, it's better use a private blockchain. It's a Monero. You can send any transaction. It's whole private. Nobody can find anything. Even a developer, they can't find anything. It's most of the most private blockchain out there. It's used by criminal and multiple people. So yeah, Ethereum is public. Anybody can see anything. You can see the whole stuff here. This is yeah. So I think I explained the stuff. Hash is simply the hash of this block, the ID. This is the hash of previous block, the parent block. I told you like they chained. So this hash contained hash of previous block, this block. You can see here 714, 714, 713. They chained. Uncle block. So what happens sometimes two miner can block they can mine a block at the same time. When two blocks are mined at the same time and they are broadcast at the same moment, only one block will be accepted by the nodes. So the second block, they call it anchor block. It gets some reward, but not everything. It gets some reward, not some reward. The main block get added to the chain. That block, the miner gets some reward, but that block is ejected. And that's it. So this is the whole block and transaction. So again, any question? So any question you have? So if no question, so
yeah, I guess we can move forward with proof of work. Anyone is having any question, feel free to add it to the chat. And at the end of the session, we will have like 10 minutes for the Q&A as well.
yeah.
Thanks, Sanjeet.
So proof of work, proof of stack. So the 4.0 problem is proof of work. So multiple blockchain, Bitcoin, Ethereum use proof of work. It's very old way. So proof of work, proof of stake, they are part of something called consensus. The way all this node agree on one state of network is called consensus. Proof of work is part of consensus only. It's a part. Okay. Proof of work, simply we need to solve a very hard problem. We need to compete with all nodes to solve that problem, to mine a block to get a reward. Proof of stake, we need to first take some coin, then we start. Also, there's no competition. When I stake a coin in a proof of stake, the network choose a node to mine a block and other nodes to validate the block. That's the main difference between both. How to set up, so Manish, how to set up how to set up the private act as a key, how to set up a private account or private key. Yeah, okay, so if you want to use a private, so Monero is actually a blockchain. Monero is a other blockchain. Ethereum is a blockchain. Monero is a other blockchain. If you want to use a private blockchain, go to Monero, get monero.org. You can make account there. Simply you need to a wallet for that. So you can't make a private account in Ethereum. It's a public blockchain. You can't make it here. Okay. So here. So proof of work, solve some problem like a very hard problem. Proof of stake. Stake a coin. You can now mine. Also, the network will choose you when you want to mine. You can't start mining yet. Network will choose you to mine and some other nodes to validate. So to start mining, producing or adding block, we don't need to stake coin. We just to start mining or producing adding block, we need to stake some coin here. Ethereum is proof of work. It will this year. So there's a question, Derek. Why some Ethereum banned token out of circulation instead of keeping in the circulation? So Ethereum is a inflationary token. There's no limit on Ethereum. Ethereum can like so every time the miner are mining a block, they're getting Ethereum. There's like no limit how much Ethereum are there. The blockchain can give you Ethereum maybe for century. Okay, so there's no limit. Okay, so if this happen, the coin will go like the supply will go up and up and up. Then the price can go down because there are more coin now. Bitcoin has 21 million supply. There will only be 21 million Bitcoin. So it has some limit. Ethereum or Ether doesn't have any limit. Ether, the cryptocurrency, doesn't have any limit. There can be infinite Ether. There's no limit on Ether. So they need to like a way. They need to find a way to increase the price of Ether. So they're taking some coin out from circulation. So now when we take like same supply go up and up, the demand can go down, or simply the price can go down. If you take like we simply take some coin away from the supply, we can maybe increase the price. So that's what they're doing. They're trying to increase the price of Ethereum. So that's why they're burning the coin. Shiba Inu, they also burn some like 50% of coin to like increase the price. Multiple people, like multiple blockchain, multiple people do it simply to increase the price of the coin. There's a less supply, price will be up. There's more supply, price will be down. Simply decrease the supply, price will go up. So that's why I like to burn the coin. So here we don't stake coin, we stake the coin. This is a competition. Every miner compete with each other to solve the puzzle. There's no competition. The network choose the miner who will mine the block. Sometimes it choose on the stake. How much coin stake, the more chances you have to mine a block. Other validators simply they validate. Other nodes simply validate the block. It's right or no. So why? So why Ethereum is going from proof of work to proof of stake? Ethereum annual energy consumption is like equal to country like Austria. So like it consumes too much energy. Its energy consumption is like to a country like Austria. Austria is like in Europe. So here. So with proof of stake, since everyone doesn't need to compete, it's like whenever we choose a miner, he will that node will mine, other will simply validate. So in that sense, we can decrease the amount of resource we need to mine a block. So Ethereum energy will soon decrease by this much percent with proof of stake. This year, so Manish, do you recommend to have Monero? Yes. Yes, I would say Monero, Gcash, and lot. So I would say it's like private. I'm a developer. I like that coin. That thing is very advanced. Like I check the document, they're very advanced. The way they work is very good. So as a developer, I like Monero a lot, the blockchain. But you can use it if you want or not. It's your choice. Again here, everybody like the competing here simply like one node or few node need to mine, other need to validate. So that way we can decrease a energy consumption. The energy we need to mine a block. So Ethereum they predict that they can uh, like lower this much amount of energy with proof of stake. This year, Ethereum is going from proof of work to proof of stake. This year, this year the upgrade gonna happen. One more thing, proof of work they call it miner. Proof of stake the node are called validator. Since some mine, some validate. Most of them validate the block, so they called validator. One more thing, proof of work anybody can like try to mess with the blockchain. We can't uh, punish them anyway. Proof of stake, they stake some coin, like they give some coin to the network first like for starting the mining. So if a node go offline, they can take some coin away. If it maybe node try to include a fake transaction, we can simply take the whole stack away from the node. So this is actually again a way to also punish a node. So proof of work take too much energy, proof of stake take less energy. Proof of work we can't punish node. Here we can. We can take the coin away. Because they need to stake some coin to start mining. So here, smart contract. So this slide. Smart contract is simply a program that runs on the Ethereum blockchain. It's a collection of code, function, and data that simply you can call it. It's a code deployed on the blockchain. It get executed when somebody make a transaction to it, or a code on the blockchain that get executed when certain conditions are met. That's a smart contract. It can do pretty much anything. dApps. So dApps or decentralized application are built on a decentralized network like a blockchain. It combines smart contract. Smart contract is more like a backend. It has a front end. So dApps has a front end like JavaScript or something, backend as a Solidity or smart contract. On Ethereum, the smart contracts are actually accessible and actually they're open source. I will show you what I mean. Let's go here. And you know the Shiba Inu. So somebody you know the Shiba Inu, heard about it. So Shiba Inu is a token on Ethereum. It's simply a contract actually. It's a code. Okay. So here's a contract. I can't read that contract. But if you go here, click this thing. This is a contract. It is a address. This is a code for Shiba Inu. You can see the whole code. The whole code is here. Then there's some like method here. So if maybe you can see the name, total supply, decimal. They can divide it with 18 decimal, symbol, balance. Simply add address here. They will give you like how much you have. So if I take this thing, put my address here, query, I have zero Shiba Inu and more. Yeah. So the code is open source. You can see the whole code here. The whole code is here. Back here. So in the dApps, there's a front end written in JavaScript or something. JavaScript framework. Back end is the smart contract. Smart contract talk with the blockchain. So that's how we do it. So in a traditional web app, so it's more like front end, back end or API, and a database. But in dApps, we have front end, smart contract, and blockchain. Smart contract talk with the blockchain. Blockchain is more like a database. Smart contract is like code, a backend. Front end could be anything, a JavaScript or anything. So what's happening in the crypto world now? So again, any question here? For smart contract and dApps. So if no question, then I will go over. So what's happening in crypto world? So the DeFi. So I'm gonna prove this thing now. Okay, that's yeah, yep. So DeFi is a finance built on blockchain technology. Uniswap. Uniswap is a app on Ethereum. Go here. Yep. Hide here. So it's permissionless, simple, global, and open. So DeFi is a finance built on blockchain. It's first, it's like open and global. What do you mean? So to work with Uniswap, I click here, connect wallet. Again, wait, I already have it here. So maybe let's use that too. Next, connect. Yep. So the DeFi, everything is open and global. Simply mean that if we want to use anything here, you don't need anything. You don't need email. You don't need income. You don't need anything. So like, if you want to like open account in a bank, you go there. You show them every ID, other stuff to open an account over here. In a DeFi world, simply you need anything. So this all app, they ask nothing from you. They don't ask you email, name, your age, income, your history, anything. You simply go here, connect wallet, and that's it. And for Uniswap, I'm this thing. I'm simply address. So this is DeFi. So this is a one product with DeFi. It's open and global. Anybody can access this finance. There's no limit. Uniswap is used to swap token. So let me say I want to swap like this is my Ether with maybe Uni. Yeah. So I can swap this one Ether with this token. So it's a protocol or app for swapping cryptocurrency. It's open, anybody can join. There's no limit. Like nobody will ask you anything. It's open and global. Second, trustless. Simply a code. Simply it's a code. It's made by code. Decentralized. So this stuff. What do you mean? So so here I can swap token, right? So who provide a token? People. So decentralized simply mean that the application is not controlled by a central authority. On Uniswap, there's no team, there's no giant group who come here who give the token. You can go here, you can provide your token here for people to swap. When I swap a token, they charge me some fee. People who provide token here, they get their fee. So, peop- so people are one who's swapping token. People are also the one who provide token. There's no standard authority. Nobody is like here is the main authority that can control Uniswap. So it's open, anybody can join, no limit. It's actually managed by the whole community. You can also provide token. There's no limit. You simply need a token. There's no limit here or any barrier. Anything you can do. Simply you need a token first. You need a token, right? So that's why. So DeFi is permissionless, simply mean global and open. You don't need any permission. Trustless is a code. Trust the code or simply see the code. Decentralized. Nobody control it. Open source. The source code is open. It's available on the GitHub, also on Ethereum as well. You can see the code. A finance built on blockchain technology is DeFi. And this is all the property of the finance or a DeFi. So at this moment, we have so many apps to borrow, lend, swap, save, invest, and trade. Multiple are on Ethereum. Also, they are available on Solana and other blockchain. So that's DeFi, a finance built on blockchain technology that's open to everyone. The source code is also open. You can read the code. Nobody control anything. You can swap token, you can give token, you can borrow land, you can do anything. That's the main stuff. That's a DeFi. NFT, again, it's simply a token used to represent the ownership of a unique item. Simply they use like tokenize unique asset. That's NFT. So here I added this thing. NFT in some sense is a ERC fungible token. This is actually a NFT is a smart contract. So any smart contract that implement this method and event is an NFT. Simply is a code. There's a token standard. So if you want to build an NFT on Ethereum, you need to follow this thing. You need to implement all this method and event to be called NFT on Ethereum. Back, yep. So you can pretty much like tokenize art collectible. So recently, so first time in the history of US, somebody sold a house as an NFT. So why does it matter? So if we can sell house or other stuff as NFT, it make it very easy. So NFT is simply a token. The idea of NFT came in 2018. Simply developer wanted to take an asset, make a token for it as ownership, and simply exchange that token. Right now, if you want to sell house, you need to like go to some company, help them like put ad for you, do a lot of stuff. With NFT, simply you can exchange that token. Simply like buying or selling something like a house can be made easy as doing a transaction on a network. DAO. So what is a DAO? So in a DAO, a, it's a member owned community. So simply in a DAO, a very simple sense could be there are people in a community, they get something called a governance token. They use token to vote on the system. So maybe yeah, I can show you this way. So I told like nobody control Uniswap, right? It's right. So wait, I need to, yeah, Ethereum, the mainnet. Yeah, go to mainnet. Yep, vote. So the update to the Uniswap, who decide update? People. So if you want, let me see, if you want like a do something on a Unify, you think it's a better for this app to have this functionality. You can create a proposal here. People who trade here, they get something called a uni token. The uni token. This is token used to vote on a proposal. So they did this proposal like if they want to deploy this Uniswap on Polygon or not. People agreed. When they agreed, the code got executed to deploy it to Polygon. So people provide so for people provide token in the pool, they provide token. There's a swap token here. They are the user, there's a producer. They also govern this app. So there's no standard authority. It's the people. They are doing everything here. So that's a DAO. In a DAO, people have a token, governance token. They use this token to vote on the direction of the organization. In one sense, it's actually a smart contract. DAO is a smart contract. Beyond finance, so there are some application of blockchain beyond finance. This is a Filecoin. So it's actually a peer-to-peer file storage system. So simply it's a decentralized cloud storage. You can store your data on Filecoin. It's faster than Amazon and cheaper than Amazon at this moment. It's actually now it's a very big enterprise, Filecoin. VeChain. VeChain is used to mostly track is stuff in supply chain, like a product from the start to the finish, which is used by BMW, Walmart, and other enterprises. It's an enterprise blockchain. Pre-search is actually a search engine. So you can so there are multiple node. When you send the search here, first the gateway remove your IP address, send the search to node, node result, node do the stuff, return the result to gateway, then they get to you. That's a pre-search. It's a designed search engine. It's not a blockchain, but they have a pre-token of cryptocurrency. If you want to put an ad on pre-search, you need to buy that coin. So pre-search, the whole medium of exchange in pre-search is a cryptocurrency called pre. So if you want to put ad on pre-search, you don't pay in Canadian dollar, US dollar. You need to buy pre-token and use the token to put ad. That's pre-search. Gitcoin. Gitcoin is a platform where you get paid to work on open source. So they do a lot of stuff. But our stuff is actually so this open source repo there. The developer can put some coin. So anybody can solve this problem. They can get a coin. So that's what Git can do. Also, they fund multiple project in Web3. Akash is a world first decentralized open source cloud. So again, it's open source. It's actually decentralized. So they're peer. So if you want to run a VM, some node will run it for you. There are multiple node that do the stuff for you. It's decentralized open source. So they are like use cases beyond finance for blockchain. These two are blockchain. These two are not blockchain, but they use that technology. Also, they have their own coin. such as pre-token to work on it. Gitcoin has Gitcoin that you can earn by working with open source. Akash has Akash coin that you need to pay to like deploy a VM or something. So this is like the use case beyond finance to show that. So the popular blockchain right now, the most popular blockchain. So first, any question?
I think we are good, Daljit.
Yeah, for sure. So the popular blockchain now, the Bitcoin, Ethereum, Cardano stone. So I can't like tell everything about them, but I can say like a little bit of everything. So Bitcoin was the first blockchain. It was started. So the first idea of Bitcoin was introduced in 2008 by Satoshi Nakamoto. The first implementation of Bitcoin in a code in C++ happened in 2009 by the same Satoshi, the guy. Later currency is BTC, again Bitcoin. It's generation one. It's simply a ledger. It store transaction. It takes 10 minutes to mine a block. Transaction fee are very high. It like if you do a transaction in USD, it would be more than $1. Ethereum. Ethereum actually the idea of Ethereum came in 2013 by somebody called Vitalik Buterin. So Vitalik Buterin was a software engineer who was actually following the Bitcoin a lot. He actually co-founded a Bitcoin magazine. So he saw the problem of Bitcoin that it was just a ledger. So you can do transaction, it was okay. But other people who wanted to like do the same stuff, like if they want to implement something like a Uniswap for swapping, they need to take the whole code of Bitcoin, implement on the top of that. So it's very, very hard. So they found Ethereum. Ethereum was an idea or like a protocol to build application on the top of the blockchain. That's a smart contract. So that's why Ethereum is like a ledger. So you can do transaction on ledger, but also you can deploy your own code. It's generation 2. It takes 40 seconds to mine a block. And the fee are very high again on Ethereum at this moment. Cardano. So the Charles Hoskinson, the one of the co-founder of Ethereum, left Ethereum to find Cardano. So Charles Hoskinson simply wanted the Ethereum to be for-profit entity. He wanted one more entity which would be for enterprises. Vitalik was against the idea. He simply wanted Ethereum to be non-profit. So he left Ethereum, found his own company. Then, after founding his company, he started developing Cardano, a blockchain which would be like Ethereum but more faster. The main is launched in 2017. The main implemented code was launched. If you can see, it's ADA. It's also you can deploy a smart contract. You can do transaction in smart contract. It takes 20 seconds to mine a block. Fee are very low. You pay less than 1 cent on Cardano for transaction. Solana. So Solana idea actually came from one of the best people who who have did multiple great venture like startup multiple thing. So Solana is actually one of the most fastest blockchain as cheap blockchain. Launched 2019, token sold. Also ledger, you can do transaction, you can deploy your code. You can see it takes 0.4 seconds to mine a block. It's very fast. It's more faster than Visa at this moment, the Solana blockchain. It takes like less than the cap is 1 cent. So for the fee we pay in Solana is the top is 1 cent. We never pay more than 1 cent in Solana. The fee is less than 1 cent. Polkadot, Cosmos, Avalanche. So now the idea is different. Dr. Gavin Wood from Ethereum. He was one of co-founder from Ethereum. He wanted to make something called Polkadot. He also the guy who coined the term Web3. So what is Web3? So Dr. Gavin thought that we had too many blockchain. Maybe we can somehow make a network blockchain. We can make all this blockchain communicate together. So first, Bitcoin Ethereum can't talk actually. You can't take Bitcoin and simply send to Ethereum. You can't take Ethereum send to Bitcoin. It's very hard, very hard. It's about a thought of idea. Maybe we can take all this blockchain and form a network in some sense. Blockchain and network, they're P2P network. They can one more network on the top. So this already become Web3. He coined the term Web3, Internet of Blockchain. There are multiple blockchain, their network. This network would have one more network. It's like an Internet of Blockchain. So that's Web3. Polkadot is like that. So Polkadot is very hard to define what it do. So there are three chain on the Polkadot. Almost three things on the Polkadot. So first, this is a relay chain. The relay chain is the base chain. So relay chain is where we do the transaction. Relay chain only handle transaction, okay? So on the top of the chain, there are 100 parachain. The parachain are actually any chain that you can build. You can build your own chain on the Polkadot actually. So instead of building a smart contract or deploying a smart contract code on the blockchain, you can build a blockchain on the top of a blockchain. So that's Polkadot. So this parachain is simply a parallel chain. There are total 100 parachain at this moment. The limit is that much. So this chain can have anything. They have proof of work, proof of stake. They can do anything they want. The transactions are done by relay chain, the base chain. So relay chain, transaction, parachain, are your chain. You can do anything on that. This 100 parachain can communicate with each other. They can talk with each other very easily. Then there's a bridge. If you want to talk with Bitcoin and Ethereum, you can use bridge. Cosmos. So what is Cosmos? So Cosmos, the idea also came somewhere in 2014. Same thing as Polkadot. Internet of blockchain. With Cosmos, you can build your own blockchain. After building your own blockchain, you can use something called IBC to communicate with other blockchain. I sorry, I actually didn't did this thing. So Polkadot, the coin dot, 6 seconds to mine a block, fee very low. So these are three chain, they can are ledger. You can deploy a smart contract. Again, you can deploy. This Polkadot actually has a copy of EVM on its one of chain Polkadot is simply EVM. You can deploy your contract on that chain. Multi-chain, you can build your own chain instead of deploying a smart contract, and this chain can communicate with other chain on the network. Cosmos, same idea. You build your chain with Cosmos SDK, a framework. Then use something called IBC, a protocol to communicate with other blockchain. That's Cosmos. The coin Atom take 1 second to mine a block. Fee very low. Avalanche, last chain we're gonna talk about. Avalanche was started, it was started somewhere actually in 2018 somewhere. 22, the first implementation, the mainnet launched. Avalanche has three chain: X chain, P chain, and C chain. X chain do the transaction, same as relay chain. If you want to build your own chain, that's P chain. You can build your own chain, a parallel chain, or a platform chain. If you don't want to build a chain, you will simply deploy a contract. This is C chain. It's a copy of EVM. It's actually an EVM. C chain is EVM. You can deploy that thing on that C chain. AVAX currency, 3 seconds to mine a block. This much low fee. So any question about this chain? And I can also give like any tip for development on any of the chain if you want. So if no, I can go over next one. Wait. So I can talk about this chain again later. But first, this stuff CBDC. So what is CBDC? So you can't regulate cryptocurrency. So the bank, not only the government, they are issuing their own digital currency, the CBDC. It's like a digital token, but issued by the central bank. China was the first country to issue a CBDC, central bank digital currency. So the CBDC that China had, they call it digital yuan or yuan. That is it currently in test. They haven't launched it. It's in test. Actually, at this moment, around 9 cities in China use that currency, that digital currency. So that India is going to reach their own digital rupee, their own currency this year or next year. They announced it in January. Then US. So if you want to know about the US, so you can click here, Hamilton. So 3rd of February, MIT and Federal Reserve Bank of Boston did some test on CBDC. This CBDC they are testing, it will be digital dollar, digital US dollar. There's a whole research, like they're testing the stuff. So government can't control cryptocurrency. So they want to build their own currency. So that's CBDC. And so this is advice again. If you want to get on a blockchain, don't invest in Moon, Coin, or next hype, anything. Invest in good technology that you think can change the world. That would be my advice. Simply don't invest in any Moon, any Shiba, any Shiba Inu or something. Rug pull is it so? There are too many scams in crypto world. So again, there are too many scams in the crypto world. A drug pull is the most a common scam. In this scam, the developer actually make a project that they come with the idea of some blockchain. They say this is the next Bitcoin, Ethereum, Polkadot. Then they simply like take a coin, simply did a ICO. In ICO, simply they launch a cryptocurrency. You can launch cryptocurrency like using Ethereum something. You can say that this is my coin. So you can give this coin to investor. You can say if you use a Bitcoin, for one Bitcoin, I will give you 10 my coin. So they exchange this way. So they think that this maybe this project or blockchain can go up, like it could be one next big thing. So they invest that way. After they took all coin, they run away with a fund. This is the most common scam on in Web3 world on blockchain. Some resource to avoid scam. Yeah. So any question? So I think I like did too much thing, but yeah. So any question about anything? So any change, like if you like the change, ask any question for me. I know. As if you're like start, maybe you start slow now. Any question? Let me know.
Thank you so much, Diljit. The session was very informative. I personally have a question. What resources would you recommend for newbies? Like, if I'm new to the blockchain thing, I would like to start.
So
What resources would you recommend to start with?
it's better to work on generation 2 blockchain than 1 or 3. 3 are complex, 1 do nothing. By the way, you can launch a smart contract on Bitcoin. So Bitcoin by default can't do it, but there are 3 technology. There are 3 company or party. They have some technology. So how to define? I can define it this way. Bitcoin is layer 1. It's layer 1, okay? They have an interface that can deploy a smart contract on that interface. That interface can communicate with layer 1 Bitcoin. If you want to work on Bitcoin, you can work with smart contract, but I don't recommend. Ethereum would be the best. Ethereum is one of the still one of the best chain. Around 80% of the DeFi world, DeFi application run on Ethereum. It's bigger than all this chain. But still, it's not hard, bad to work on Solana. It's very good chain. It's very fast. It's the fastest chain out there. So if I work with Ethereum, click here, go here, developer, document, read all the stuff. That's it. Like it will give you some knowledge of what they are. After you get a what is it, Ethereum, everything, there are actually 4 language. The 2 language for the smart contract, Solidity and Vapor. There are 2 language for EVM, UL and U+. It's better to learn Solidity to understand what is a smart contract. After that, you can go to any chain you want. Go to Cardano, Solana, Polkadot, Cosmos, everything. There's also something called Phantom, Near, the lot. But still, Ethereum is still one of the best.
Okay, sounds great. Thank you. We can start like 5 to 10 minutes for question. Would you like to grab some water? You have been talking for almost 2 hours now.
Sure.
Feel free to add your questions in the chat, and I will be pasting the link for our presentation.
Yep.
So let me get the link here. Okay.
Again, so you might like not understand what's a blockchain now. It's very hard. So yeah, it's very hard to understand what is a blockchain because people see blockchain as a ledger. It's more than ledger. Like Ethereum has a virtual machine inside it. So it's like better maybe to simply start very slow, read some thing about what is Ethereum again, the document, They try to see like more and more, like it divides Ethereum into multiple layers. So there's a layer for data to store data. There's a network layer for to communicate with nodes. There's a consensus layer where they agree on one state. There's a layer for to give reward. There's a actually layer. There's a layer for virtual machine as well. There's application layer. So again, it could be hard like to understand what's a blockchain, but still start.
Thank you, Daljit, and thanks a lot for our attendees who waited the whole workshop with us. You can share with us where are you from, what are you studying, and have you been a member? Yeah, I can't see. Okay, let me bring it here.
So yeah, so sorry if I like pronounce your name wrong. Can solid be used for Bitcoin as a blockchain? Yes, actually, so Bitcoin you can't use solidly. Actually, maybe try. There are like 3 technology that can deploy as smart contract on Bitcoin: stock, root, RGB, and stocks. Maybe how can you try this 3 word? Stock root, STOCKROT. See what they use: RGB, RGB. Stocks, S, no stocks, stacks, sorry, stacks, STACKS. Bitcoin, I don't know totally. That technology I don't use. But Bitcoin is not a good chain. Or it's very slow, everything. You can work with Solidity on Avalanche. The C chain is a copy of Ethereum. You can work here. After you work all these 3 chain, you can work with Solidity, Polkadot and Cosmos, Avalanche. Solana use 3 language: C, C++, and Rust. It does use Cardano use something called Haskell language. So Polkadot, Cosmos, Avalanche, you can use Solidity. Ethereum can use Solidity. Bitcoin, I don't think.
Sounds great. Let us know in the chat, how did you find the workshop? Confirm accessing the slides if you would like to in the chat. And if you are also looking for more workshops, our chapter at Sheridan College are hosting multiple workshops, like for Java, object-oriented. Daljit is also hosting another workshop for Python for beginners. We are having a lot in our chapter. Make sure to stay tuned with our events. And thank you so much for coming today.
Yep.
Hashcode is back. Hashcode is a team-based competition with 2 single problem rounds. To compete, you'll form a team of 2 to 4 people and work together to solve an optimization problem. You won't want to miss the excitement of Hashcode, which sees nearly 100,000 programmers competing simultaneously around the world. Join a global community of more than 400,000 developers. Approach and solve problems in creative ways, grow your programming skills, and most importantly, have fun. Register for Hashcode today.